Here in this video, we are solving two questions that appeared in NEET 2022 from the chapter Nuclei. Questions are simple. Let us try to understand what they are. The first question is, in a given nuclear reaction, element X is. So what is given for you is Na1122 has become something X plus, that is E plus, that's a positron, and a kind of a neutrino. Now, first thing that you need to understand is this is positron has emitted. That means this must be a kind of a beta decay, because in the case of an alpha decay, helium-24 will be emitted from the nuclei, but here what happened is this is a kind of a beta decay. There is possibly two kinds of beta decays, right? What happens is from the nucleus, a neutron can split as proton and an antineutrino. That's one possibility. So what happens in that case is neutron became a proton, means the mass number A remains the same, but as a new proton came, atomic number increases by 1. That means Z becomes Z plus 1. That is one possibility. There is one more. So, but in that case, there is no emission of a positron, because proton is emitted with a positive charge. But there is another possibility that the proton inside the nucleus can split up as a neutron and a positron and a neutrino. So this one, what is given for like a positron is this case. So being proton became a neutron, the total mass number A remains same. As one proton is lost and what is generated is a positron, is a positive electron, its mass number, who is the number of the protons, decreases by 1. That means Z becomes Z minus 1. So in our given case, Z has to become Z minus 1, right? So Z minus 1, it has to be, yes, this one. So the 11 becomes 10, 22 remains same in E, but this is a technical mistake, that this is also being given like the same, both C and D are same, but this could be you could have given as something like this, right? So but that was missed. So that's how it is going to happen in the case of a beta decay. Let us see what happens in the second question. A nucleus of mass number 189 splits into this. Ratios of their radiuses. You need to know that volume of a nucleus is directly proportional to mass number. Assuming it's approximately spherical, volume of a spherical body is 4 by 3 pi r cube, is directly proportional to A, not A cube. R cube is directly proportional to A. R is directly proportional to A power 1 by 3. That can be further written as R equal to R naught into A power 1 by 3, but that's not required for me right now, because we want the radius of ratio A1 by A2 whole power of 1 by 3. Thus given that A1 is 125, A2 is 64. So 125 by 64 power of 1 by 3. 125 can be written like 5 cube, 64 can be written like 4 cube, whole power of 1 by 3. These cubes and 1 by 3 will cancel, so the ratio is 5:4. That's how we solve that question. Thank you for watching.